Hello, 6th graders. Welcome to your video lesson on ordering positive rational numbers. Your learning target today is that you can compare and order positive rational numbers using conversions. So these are your fractions, decimals, and percents that may be all shown to you, and you figure out how to put them in order, least to greatest or greatest to least. Per usual, we want to stop and think about what we already know. How would you know which is the larger ratio when given varying fractions, decimals, and percents? So stop and think about what you might try first, and then let's review some vocabulary. Greater than, right? We want to remember that the symbol for greater than is reading it left to right, greater than what's on the right. Less than, we read left to right, less than what's on the right. Equal to, we know means they are equal. A number line is just a line that we use to place numbers on that can vary. We have 0. To the left of 0, which numbers we haven't talked about yet, are negatives. To the right of 0, we have our positive numbers, and they could go by different increments. You might have the increments going by ones, you might have them going by halves, and kind of going from there. So knowing that you can pause and write down whenever you need to. So if you think back to your question of how would I know which is larger when looking at these, fraction, decimal, and percent, the trick is you want to change them to be the same form, so comparing them to the same number. So what I would do, and you can write that on the last page or right here, is to compare, we want to change all to the same form. Meaning I might want them all to be fractions, I might want them all to be percents, or them all to be decimals. Depending on what I'm looking at, I might change my mind. So see if you can fill in the blank with less than, greater than, or equal to make each of these sentences true. You might decide to do a couple with me, or pause, try on your own, and then check. You decide. So for 4/5 compared to 7/8, I could divide them and change them both to decimals. I could change their denominators to be out of the same number. Or this cool little trick for fractions is I can check their cross products. I can multiply here and I get 32. Can multiply across and I get 35. So I see that 4/5 would be a factor of 32/40 compared to 35/40, so this is less. When doing that, you're assuming that you'd also be multiplying the bottom by that same number. So the equivalent fraction here would be out of that 40. Next one, I might decide to change this percent to a decimal or the decimal to a percent. So I know to change to a percent, I'm going to multiply by 100. So this is equal to 12.5%, which 12.5% is greater than 10 2/10. See if you're feeling confident? Give it a go. For this one, I might change, and again, you decide what works best for you. It's how your brain works, and that's awesome. So for me, this is a decimal that's nice already. I know the equivalent to 5 2/5 is the same as 20/50 or 40/100, and so I know that 40/100 is 5 4/100, which is less than 43. So I don't write the less than symbol because I read left to right, greater than. Another one, I might decide this 5/6 doesn't have a nice denominator. It's pretty small denominator to get to 100, so I might divide instead. And you can do long division, 5 divided by 6, or you can use a calculator at this point too. But I do know that it is going to be close to closer to 1 because 5 out of 6 is 1/6 less. So I know that this is 0.83 repeating, which is greater than 625 thousandths. 30% I know is the same as 3/10. This one's tricky for people. If I change this to or 3/10, if I change this one to a decimal, it's 3/10 repeating. So this 30% is less than. And then one more, we have 35/100 compared to 3/8. 3/8, again, I might just decide to change to a decimal by doing 3 divided by 8. So I have 35/100 compared to 375 thousandths. Remember, comparing them to the same value, 350 is less than 375. So see how you're feeling. Maybe you want to come up with your own to try. See how you do. So now writing those least to greatest, same thing. You can convert to work on them, but your answer should always be in the original form. So again, you decide if you're ready or you want to watch a couple before you go. So I know 1/4 is a pretty common 25/100ths equivalent. I could have divided, or I could have changed it by multiplying by 25 to get 25/100ths. So then I see that that is more than 2/10 and more than 22%. So least to greatest would be 2/10, 22%, and then 1/4. Over here I have 1 and 2/10, 100%, and 8/9. Right away, I know that 100% is equal to 1, and I know that this is greater than 1, and 9/9 would be equal to 1, so 8/9 is less. So I don't really even have to do a lot of converting. I just compared them all to one whole. So 8/9, 100%, to 1 and 2/10. Are you ready to try on your own? Here I see this one's greater than 1 whole, so I already know that that one's the biggest. Again, just me sharing my thinking. I see I have 4/10 here, which is the same as 40/100ths, which is the same as 40%. So those are the same. Whereas if I read this one, I can read this one as 4/100ths. I know 4 is less than 40, so that's my smallest. So I have 4/100ths. These are equivalent, so they could be in any order. Those are the same. And then 2 and 4/10 is the biggest. Last one, 11/4. I know that's bigger than 1 whole. All of these are. So I might just want to decide, we have 2 and 3, which I know is 2's less. So for this one, I might just want to change to a mixed number. 4 goes into 11 2 whole times for 8, with 3 of the 4 left over. 13/5, 5 goes into 13 5 times. Sorry, nope, just kidding, 3 times. 3 times. Just kidding, 2 times. What is wrong with me? 2 times for 10, and that's with 3 left over. That's what I was trying to say. So I can automatically see that 3 and 1/10 is the biggest. Then I just have to compare these. So maybe I change these to decimals. This is 2.6, so I see I have 2 equivalent ones here, and they are the smallest. So 2 and 6/10, 13/5, 2 and 75/100ths, and then 3 and 1/10. See, we all make mistakes. Bear with me. All right, so lastly, putting on a number line. Remember, you are in control of the pace here. Pause when you need to. Try on your own. Ordering them on a number line. So we have 0 through 5. Looking at this, trying to figure out how many lines there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means each of these is worth a half. So you might have 1, 2, 3, 4. That's helpful. And so we're going to do 6/10. I know is slightly more than 1/2. It's 1/10 more. So maybe I'm putting in each line here that represents a 1/10. And so 6/10 is going to be 6/10 of the way to 1. 3 and 2/10 is going to be past the 3 and 2/10 in. 40% is the same as 4/10 or 40/100ths. So that's going to be just to the left of 1/2. And then we have 1/2, which is right there, already labeled. 5's halves is the same as 2 and 1/2. So we're going to go to 2 whole numbers and then halfway. And then 24/8, 8 goes into 24 3 whole times. So that is equivalent right here. Maybe try to see if you can put your own numbers on. All right, that is it for comparing and ordering. The trick is to put them in the same form and have it make sense to you. Have a great day.